Hi, this is John Ainsley, CTO at Doulos. This video is a tutorial on transaction classes in UVM. In this video, I'm going to be taking advantage of the easier UVM coding guidelines and code generator. Now, this video isn't specifically about the easier UVM code generator, but nonetheless I used the easier UVM code generator to create all of the examples that you see here. And of course you can download the easier UVM code generator and recreate all the examples for yourself if you want. Just download the code generator from this URL. If you've seen previous videos in this series, then you'll know that we use the convention that automatically generated boilerplate code is going to be shown in black text, and user-defined code fragments inserted by the code generator are going to be shown in blue text. So the code in black will always be the same, the code in blue is going to differ according to the specific features of your application. So here goes. There's two main use cases for using transactions within a UVM verification environment. Transactions get passed from the sequencer to the driver, and transactions get distributed from the monitor for checking and analysis by components higher up throughout the verification environment. So the driver will call the get method to get a transaction from a sequence running on a sequencer. The monitor will call the write method to write a transaction out through an analysis port, and that write method will get implemented within a subscriber that receives the transaction. So as transactions get passed around the UVM verification environment, you'll sometimes need to call their methods such as copy and compare. And there's various use cases for these methods, so you might call the copy method within a subscriber to take a copy of a transaction for later. The compare method is often used within scoreboards. The pack and the unpack methods are used when packing the contents of the transaction on a vector or sending them across a serial link. And then the print method might be used in a monitor just to print out the contents of the transaction for diagnostic purposes. So in this tutorial I'm going to explain these use cases and also show you how to define each of these methods for yourselves and help you to understand what's really going on. So there's various classes involved. In UVM there is a class UVM transaction. UVM transaction actually extends class UVM object, and it's the UVM object base class that actually has the copy and compare and print methods. But the class that we're mainly going to use with transactions is UVM sequence item. So if you're creating your own user-defined transaction class, you'd do that by extending UVM sequence item. And the reason for that is if you want to generate transactions from sequences, they need to be UVM sequence items, because the UVM sequence class uses the UVM sequence item class. So even though the other classes UVM object and UVM transactions certainly have their uses and are used internally within UVM, when it comes to creating user-defined transaction classes, you should always extend UVM sequence item. So let's take a look at doing that. So here's a user-defined transaction class that was actually generated by the easier UVM code generator. So you can see here in the easier UVM interface template file, we've merely had to define the name for the transaction class and any user-defined data fields within the transaction. And the code generator is then created for as a class that extends UVM sequence item, the UVM object utils macro, then the user-defined data fields, and then a whole bunch of boilerplate code representing all the methods that I'm talking about. And there's a couple of things to notice about these methods. Many of them have a so-called policy object, like comparer and printer and recorder and packer. The policy object argument here is always optional, but if you do provide it, you can use policy objects to fine-tune the behavior of the individual methods. We'll see an example of that later on. Another thing to notice is that there's an odd one out, convert to string. So most of the methods here have a do prefix, convert to string doesn't, and neither does convert to string take a policy object as an argument. There's actually at least 3 ways to create the code that you see here. The first way, and the way I'm going to recommend within this tutorial, is simply to run the easier UVM code generator, and that will do all the hard work for you. So all the examples that you see here were generated from easier UVM. The second thing you can do is to write out this code for yourself longhand, or for that matter, you could use some other code generator. The third option, which I'll mention for completeness, is to use the field macros. In Easier UVM, we don't recommend the field macros for beginners, but if as you become more expert in UVM you decide to use the field macros will create default behaviours for all of these methods. But nonetheless, if you want to do anything that's a bit special, you'll still have to override these methods exactly as you see here in order to introduce more sophisticated user-defined behaviours. So it's worth knowing about it anyway. Okay, so now we're going to take a look at each of these methods in turn, look at the use cases and help you to understand what's really going on. And we start with copy. So one of the main use cases of copy is when a transaction is sent out through an analysis port and it's received by a subscriber. The subscriber's write method is called, and the write method has to process the incoming transaction immediately because the write method is non-blocking. And if the subscriber wants to process the transaction later on, it needs to take a copy of the transaction. And it can do that by calling the copy method of the transaction class. Just like this. So here's the implementation of the write method in the subscriber. It receives the incoming transaction through the analysis port as its argument. And it's going to call the copy method to make a copy of that transaction. So the copy method is called for an existing transaction, and it takes a second transaction as an argument. And what copy does is to copy all the fields of its argument into the object whose copy method we're calling, the transaction that mitem refers to in this case. And it's critical that both transactions already exist. So copy doesn't create any new transactions. Copy copies fields between two existing transactions, in this case copying from T into mitem. So you can see that when the subscriber receives a transaction, it creates a brand new transaction by calling create, then makes a copy of the transaction it's passed before writing that copy into the FIFO by calling the FIFO's write method. So that's how you use copy. Now, how do you override copy within the transaction class? Well, that's done by overriding not copy, but do copy. So here we're overriding the do copy method of data transaction, where data transaction is a user-defined class that extends UVM sequence item, that extends UVM transaction, that extends UVM object. So we're actually overriding a method of class UVM object, and so the argument to do copy is actually of type UVM object. So the very first thing we need to do within this method is to take the argument and cast it to our own transaction class, datatx. And we do that with a downcast. So here we're taking RHS, the argument of type UVM object, and casting it to be of type data transaction so that we can access the fields of that transaction. And then we're copying the fields one by one into the target transaction. So we're setting address to RHS.address and so on for each of the fields within the transaction. So that's do copy. It's not particularly complicated. Now compare. And the typical use case for calling the compare method of a transaction is to compare two transactions within a scoreboard. So we typically compare the actual transaction that came from the design under test with an expected transaction that came from a reference model. So this is the sort of structure that you get out from the Easier UVM code generator. So the code generator will instantiate all of the code you can see here for you. The reference model you would have to provide in the guts of the reference model yourself, and for the scoreboard in Easier UVM we simply make use of the Sciasil UVM scoreboard, so that's what's being instantiated here. And if we dive inside that scoreboard, we'll find some code to compare the expected transaction with the actual transaction, which looks something like this. This isn't the actual code, this is pseudocode, but this is exactly what it could look like. So here we're calling .transaction.compare ref transaction. If the two transactions match, we print out an info message. If they don't match, we print out an error message. So how do we override do compare? Well, this is a little more complicated because do compare has to return a result. It returns a 0 or a 1 to say whether the two transactions matched or didn't match. And when you come to override doCompare, in the simplest case, all you need to do is to compare the fields of the transaction and return a 0 or a 1. And that's sufficient in the simplest cases. But it's better, in a sense, to make proper use of the policy object, because by using the policy object, you allow your users to fine-tune the comparison. So this is actually the code that comes out of the easier UVM code generator, or you could write this yourself, or you could use the field macros instead. And what the code is doing, once more, is to start with a downcast. So we're starting with the argument of type UVM object and casting it to be a data transaction. And then we're calling the compare field method of our policy object to compare the fields of the two transactions one by one, anding the result into this result variable to decide whether to return a 0 or a 1. So using compare field here is an optional refinement that allows you to take advantage of the policy object, but you don't have to use the policy object. Nonetheless, if you're using the easier UVM code generator, you get exactly all of this code anyway, so why not use it? Again, if you don't explicitly pass in a policy object when you call compare, then the default policy will be used, and that's absolutely fine. Now let's take a look at printing, and there are three methods involved: print, sprint, and convert to string. So each transaction class provides a print, an sprint, and a convert to string method. Print prints out the contents of the transaction to standard output. Sprint and convert to string both return text strings for you to use within your UVM code. The reason that there's two of them is that they come from two different ancestor methodologies. So convert to string actually was inherited from AVM, and sprint was inherited from URM and ultimately from ERM. But they're both part of the UVM standard. So both the print and the sprint methods end up calling doPrint, which you can override within your transaction classes. So here the easier UVM code generator has created this code for us. Within doPrint, we are obliged to check the value of this variable within our printer knobs object, and this variable tells us whether print or sprint was called. So if print was called, then we're using UVM info to write out a message to the standard simulation output. If sprint was called, then we're just returning a string by assigning the variable mstring within printer. So what you can see here is some of the internals of the UVM classes, but when it comes to overriding doPrint, you have to know about this stuff in order to set up these variables properly. If you use field macros, that only avoids you having to know about this stuff in the simplest of cases. But if you want to do anything more sophisticated when it comes to the behavior of the print, you're going to have to know about this anyway. And again, if you don't fancy actually writing all of this code for yourself, you can use a code generator such as the easier UVM code generator to generate it all for you. So we're doing this printing in two stages. tx.sprint calls convert to string, and then we're overriding convert to string. And convert to string is the simplest of the methods because it's a one-step process. There's no intermediate method. So with a method like print, you call tx.print, tx.print calls doPrint, which is the method that you override. With convert to string, you call convert to string directly, and this is a very straightforward, simple method that simply returns a raw text string. So you can override convert to string to take the contents of your transaction, convert it into a text string, and simply return that text string. So for completeness, it's best to provide each of these methods, which is exactly what the easier UVM code generator does. If you know that you're only going to use a subset of the methods of the transaction class, you could choose to only override a subset of the methods of the transaction class, but then your code would be a little less reusable. Now, recording. So transaction recording is something which in its simplest form happens automatically. So when we have a sequence running on a sequencer sending out transactions, those transactions will automatically be recorded to the transaction base by UVM. Unfortunately, the automatic recording that occurs within the sequencer isn't very useful because the sequence doesn't have any concept of time, and so the timestamps associated with those transactions, the begin and end times of the transactions, aren't usually very meaningful or usable. You tend to see each transaction beginning and ending at the same time within the transaction recording database, which isn't very useful. So in practice, it's much more useful to actually set timestamps at the beginning and the end of each transaction within the driver. So here within user-defined driver code, we're getting the next transaction from the sequence and then setting a timestamp on the transaction object by calling its begin_tr method. And then when the driver is finished with the transaction, it sets another timestamp by calling the end_tr method. And if you remember back a few slides ago, begin_tr and end_tr are actually methods of the UVM transaction class and also incidentally the UVM component class. So transaction recording occurs automatically within UVM, but as a refinement, we can add timestamps to the recorded transactions. Now, how about overriding that behavior? Well, that's done by overriding the doRecord method. And once more, the easier UVM code generator has generated this code for us, or equally, you could write it by hand. So here within the doRecord method, we're making use of a helper macro UVM record field to generate the necessary code to record each field within the transaction object. And there's a subtlety here. We've deliberately chosen that one of the variables here, addr, is an unpacked array, while the second variable data is a packed array, while the second variable data is a one-dimensional unpacked array. And we have to treat unpacked arrays a little differently, so we've got a for loop here to loop through all the elements of the unpacked array and record each scalar field within that unpacked array. Again, the easier UVM code generator has worried about all the details for us, or you could write all this code yourself. Now let's look at pack and unpack. So pack and unpack are used in serializing transactions or taking the contents, the structured contents of a transaction object and converting it into an unstructured array of bits. So here in a driver, for example, we might get a transaction from a sequence and then pack the contents of that transaction into an array of bits before sending that array of bits to the design under test. So if we take a look at the fields of the transaction as defined in this interface template file, we've got 12 bits of address. N, I happen to know here, has got the value of 4. So 4 times 8 is 32 bits for our data and 2 bits for our enum here. So 12 plus 32 plus 2 makes 46, which is the number of bits in this data bus. So we're taking the contents of these fields, packing them into a 46-bit array, and then driving that onto the data bus here, which is part of the interface to the design under test. And then the reverse operation in the monitor. So the monitor is looking at the 46 bits of the data bus, and on the clock edge, it's unpacking the data bus into the transaction and sending that transaction out through an analysis port. And it's good practice to use exactly the same transaction type within the driver and the monitor. So strictly speaking, the transaction in the driver needs to extend UVM sequence item because it comes from a sequence. The transaction in the monitor doesn't technically need to extend UVM sequence item, but it turns out that it's really good practice to use exactly the same transaction class in the two cases. So that's exactly what we've done. Now, how about overriding these methods? Well, of course, that's done by overriding doPack and doUnpack. And once again, there's a set of helper macros that you can use in overriding those methods. Macros like UVM pack int and UVM unpack int. And once again, all of this code has actually come from the easier UVM code generator, or you could write it yourself, or when you become more expert, you can use the field macros if you wish. So when we're packing the contents of a transaction, in this case by using the helper macros, then we're packing these fields into the vector starting at the least significant end of the vector. So address gets packed first, here's the 12 bits of address, then we've got the 4 times 8 bytes of data, and then finally we've got the 2 bits of colour which go in at the most significant end of the vector. So the fields are packed into the vector starting at the least significant end, but within each individual field, the data is interpreted as being big endian by default. So you can see the bits here are ordered from MSB to LSB. In other words, it's a big endian representation of this data by default as it's being packed in. And exactly the same with unpack. So you can see here there's a different helper macro for dealing with unpacking a field of enumeration type. And that's why we've chosen to introduce an enumeration variable here into our transaction object, just to illustrate this separate macro. So we've got a packed array, an unpacked array, and an enum, and each of those is distinguished by using a different macro here. And again, the easier UVM code generator has done all of this for us, but if you're writing this code by hand or trying to understand the code that was generated by the field macros, you'd need to figure out what was going on here. So this is exactly the sort of thing you need to understand. Let's use this as an example of a policy object. So the pack and unpack methods are methods that can be fine-tuned by passing them a policy object. Here's an example of doing just that. It turns out that one of the features of the packer policy object is to flip between big endian and little endian mode. So the default for the packer is big endian, but you can flip to little endian by setting the big endian field to 0. So here in the driver, we're instantiating a new packer policy object. We're setting big endian to 0 to replace big endian with little endian, and then passing that policy object as the second argument to the pack method. And if I then go back a slide, these macros are actually picking up the packer policy object and interpreting the value of that big endian field appropriately. And exactly the same on the unpack side. And you can see here now in the packed array, all of the bits are organised in little endian form. So we've looked at a number of methods, and we've seen that each of those methods are including the variables of the transaction object within their definitions. So for regular variables, that is variables that represent essential data that's part of the transaction and is going to be sent to the design under test, you'll want those variables included in all of the automatically generated methods. But sometimes you have metadata within a transaction class. So metadata isn't ordinary data. Metadata is data that describes the ordinary data. For example, a timestamp. Or in this particular transaction, we're including the previous value of the colour field. So the colour field within our transaction is an ordinary transaction variable. The previous value of the colour field is metadata that could be used for diagnostic purposes. Well, you typically want metadata to be treated differently. So with the easier UVM code generator, if you use transmeta instead of transvar, then the metadata is included within copy, print, record, convert to string, but it's excluded from the compare and pack and unpack methods. Because if you're comparing two transactions, you don't want the transactions to be regarded as being different just because their metadata was different. And similarly, when you're packing the fields of a transaction for sending them to the design under test, you don't want to include the metadata in the packed field. So the easier UVM code generator will do this for you. If you need to fine-tune the behavior even more, then that's where you would replace the automatically generated code with your own code, but that's really a different subject. That's about how the easier UVM code generator works. So within this tutorial, I've been describing transaction classes and all of the various methods within the transaction classes. We've seen that there's some asymmetry here because we've got a bunch of methods with a do prefix, which you override, but call them without the do prefix. So a call to copy to transactions actually calls the overridden do copy method. Compare calls do compare. Both print and sprint call do print. There is a record method that calls do record, but record is typically called implicitly rather than explicitly because transactions get recorded anyway when they're generated from the sequence. Then pack calls do pack, unpack calls do unpack, and convert to string is the odd one out because convert to string calls itself. It doesn't literally call itself. There is only one convert to string method. So I hope that tutorial has been helpful. If you want more information on easier UVM, then visit www.doulos.com/easier. At Doulos, we deliver training classes, and if you want to know more about any of the training classes that we run at Doulos, including classes on hardware design and verification, classes on embedded software and ARM, or classes on ESL and verification, then go to the Doulos website. That's all for now. Thanks for listening.